Welcome to Pivotal Data Showcase. This will be a presentation by Frank McKillen from Pivotal about encoding categorical variables with Apache MADlib.
Categorical variables, I've given some examples of categorical variables here: hair color, blood type, state of the union. And categorical variables are discrete, unordered, and more qualitative in nature. Unordered because although you may have a preference for where you live or hair color, not actually like 1, 2, 3 doesn't, that kind of ordinal ranking doesn't make sense in the context of these categorical variables. But this is very interesting information that data scientists want to use, because a lot of the data out there is categorical nature compared to, for example, continuous variables, which are things like voltages you would get off a machine, or speed, or a vehicle traveling, or pricing of a security. So we have this combination of these continuous variables as well as categorical variables that we want to use in modeling. So let's stick this in the table. Looks like this. We have the name of a person, Jane. She has black hair. She's a blood type A+. She lives in California, etc. So how can the data scientist use this information? Like, how can this be encoded to be of use in the predictive model? Now, there's some predictive models that can use this directly. For example, decision trees can use this, but many, such as your garden variety regression, cannot. So this is where encoding comes in. So the idea behind encoding categorical variables is to change them into a numerical, unbiased value. So for hair color, here we had one column. We had to divide that into, in the case of 3 hair colors, 3 different columns, or as data scientists would say, 3 different features for the model. So Jane has hair color black, so this value here is 1 for this feature. Raj and Elena don't, so it's 0. Raj has hair color brown, value of 1 here. Elena has hair color red, value of 1 here. Same idea of blood type and whatever other categorical variables there are. So if you can cast your categorical variables into this form, then you can use them in regression, as an example. So one of the new features that we've added in this version of in MADlib is a complete rewrite of an existing module there, which was called Create Indicator Variables, which was fairly limited in scope. So what I'm going to show you is a couple of the new features we've added to this idea of encoding categorical variables. So I'm using an IPython notebook. This is a client that is talking to a Greenplum database, and I'm going to load a data set. So this data set is a well-known data set on abalone, and this is a partial view of that data set. It has a row, so there's 20 rows here, so it's a small data set. So it has gender, length, diameter, height, and number of rings. So gender is categorical, male, female, or I for indeterminate, I believe. These are continuous variables, and then rings is another categorical variable, number of rings. And although it's numerical in nature, as I said before, it's categorical because 15 rings is not necessarily better than 7 in this case. So now I'm going to create, I'm going to encode this table. So what I want to encode is the gender column. I'll show you a few of the other options later, but we're starting with gender encode. So what you can see is all of the genders then have been, so we've removed the gender column, and now we have 3 columns which have been added, which is female, indeterminate, and men. So what it's done is it's actually made our table wider. And you can imagine that if you have a lot of different values for a variable, your table can get very wide. And we'll see later that we can also do array outputs so that we don't run into Postgres limits in terms of number of columns. So that's fine. You might notice here that we had some null values. I decided not to do anything with those null values. I may want to encode those null values. They may mean something to me. So we have an option here to encode null values, right? So I'm going to run more or less the same encoding, and now I'm going to encode null values. And you can see that what I have is an additional feature for my model, which includes a null value, should that be important. So a couple of other options, and these are now, just getting now into newer things that we've added in this release. One is the ability to encode all categorical variables. So what you see here is for categorical variables, I've said I want to see all of them. I don't want to exclude any of them. So we also have the option of including all of them, but excluding certain ones. And this is useful when you have very wide tables, right? And you want to encode tons and tons of features. You don't want to list them all out in an ordered list here. So what I've done here is produced now an encoding for gender, not including null, and number of rings. So you can see this is a wider table now, including 1, 2, 3, 4, 5, 6, 7, 8 plus additional features associated with number of rings, and these are encoded again with a 1 in the case for that tuple includes rings of 10. Right. So this is something else that was added recently, is encoding top values. Actually, what I should say is, where do we get all these ideas for what to put into this? A lot of it came directly from customers. We did a recent user survey. I think we did a read of this to you folks not too long ago. Options on encoding was one of the things that came back, so we've incorporated some of those. We also looked at some Python libraries that are popular in this area and looked at R to see what they did. We kind of unioned all of those and took fairly comprehensive look at it in order to kind of add all of these options in. So now I want to encode top values. I want to use the top 2 genders by number, by quantity. And I also want to use 50% of the rings value. So I can specify number of top values or a percentage, right? So if I run this again, you can see that I have the top 2 genders, and then all of the remaining ones are bucketed into a miscellaneous column. Likewise for rings, I have the top 50% of the rings, which in this case is 3. All of the other ones are bucketed into a miscellaneous column, right? So let's get this one. Let's get this one. We'll go to array output. So array output, now I've asked for an array output because say I have a very wide table, or actually it could even be a table that's not that wide but has tons of values. So now what I'm doing when I'm encoding it is it produces this, the tuple is a single, the row is a single column called encoded variables. Now, this doesn't really mean anything to us like this, so we have to produce a dictionary as well that allows you to look into that index and get values out. So part of the output, which I didn't mention here, is that we will create an underscore dictionary table for all of the associated output table if we ask for an array output. So it looks like this. So it's 14 rows, and that corresponds to an index into these 14 values here in the array. So I know that the index value here, so the first position in my array represents a gender female, right? 15th, 14th position means number of rings. Okay, so for the kind of purposes of, there's other options like how you want to distribute the data. Oh, maybe one final thing is, sometimes you want to encode floats, right? Because integers and text are the most common categorical variables, but Sometimes you actually want to encode flows, right? It could be, version 1.0, 2.0, 3.0. Those are floats, but they're, actually categorical in nature. So to do that, I would then cast it, to text or int or whatever is appropriate directly, and then I can see, right? So now I've cast height. So it said each of the individual height values is actually a new feature I want to create. So I have here, all of the heights that were in the input table have been added as new columns. So I guess to summarize, this is the utility, which is used on categorical variables to prepare data for input into the predictive algorithm.
Thank you for watching this Pivotal Data Showcase. Check out the Greenplum YouTube channel for more great videos about the Greenplum database.